Hello, this is Mr. Collier, and today we're doing the product and quotient rules. First we have a starter, which is unrelated to product quotient rule. This is a review of, I believe, some roots. Okay, so this equation has roots r1, r2, r3. Given that we have this sum equals 0, find the value of a. So first of all, I'm going to rewrite this as 5x cubed plus 48x squared plus 100x plus 2 minus a equals 0. And then we can use the sum and product of roots, because we know the product of the roots, r1, r2, r3, equals negative this divided by this, right? So that's going to be equal to negative 2 minus a over 5. Okay, so we have that equation. That's one equation we can use to help us solve. And also the sum of the roots is going to be equal to negative this number over that number, the leading coefficient. So that's going to be negative 48 over 5. Okay, so then this equation just becomes negative 2 minus a over 5, that's this part, plus this, which is negative 48 over 5, equals 0. We can multiply both sides by 5 and distribute this negative, and we have negative 2 plus a minus 48 equals 0, so a equals 50. Okay, next we're going to be looking at product rule, and this is how it looks like in your formula booklet. First, let's get the derivative of x to the power of 5 without the product rule. So that derivative would be dy dx would be 5x to the power of 4, right? Using the power rule. Now, if we do it another way using the product rule, and the product rule states that if you have a product of two functions, then it's going to be equal to one of the functions times the derivative of the other one plus the other function times the derivative of the first one, right? So basically, like in this one right here, we have two functions, one's x squared and one's x cubed, so we can do the derivative of x squared, which is 2x times x cubed, plus, now we find the derivative of x cubed times x squared. So then that gives us 2x to the power of 4 plus 3x to the power of 4. It is 5x to the power of 4. So you get the same answer. But sometimes there's only one way to do it. You have to use the product rule. Okay. Now this one here, we could expand and get the derivative that way, or we can just use the product rule. Let me rewrite that first as x to the power of half times 2x plus 5. So using the product rule, this is going to be the derivative. We'll get the derivative of x to the power of half, which is half x to the power of negative half times 2x plus 5, plus the derivative of this, which is 2 times x to the power of half. And I can rewrite this a bit. That's going to be 2x plus 5 over 2 root x plus 2 root x. Okay, let's look at some more examples. So this one here, it would probably take a while to cube everything and multiply by x squared. I think slightly easier would be using the product rule. So derivative of x squared is 2x, and then this stays the same, plus the derivative of this times x squared. So I'm going to say x squared times that derivative. That derivative is going to be 3 times 3x squared plus 5. Reduce the exponent by 1. And don't forget chain rule. You have to multiply by what's in the derivative of what's inside the brackets here, which is 6x. Okay, so after I do that, the final answer is going to be, well, let's just keep it like that. No need to expand. And this is going to be 6. Actually, 6 times 3 is 18. You're going to have x cubed times 3x squared plus 5 all squared. Okay, and then number 2 kind of works similarly. In number 2, let's rewrite that as 4x times 4x plus 5 to the power of half. Okay, so to find the derivative of 4x is just 4. So we have this plus 4x times the derivative of that, which is half, times 4x plus 5 to the power of negative half, times the derivative of what's inside the brackets is 4. So let me simplify that as 4 root 4 plus x, 4x plus 5. Plus, I've got 4 times half is 8 x, and this I can write in the denominator root 4x plus 5. Okay, and now we have another product of functions. One function is x, the other one's ln x. So the derivative of ln x is 1 over x. So we find the derivative of ln x times x. That's our first term. And then we're going to have derivative of x is just 1, so it's going to be just a ln x. So here the x's cancel, it's just going to be ln x plus 1. So next one, we have a product of functions, this one and this one. So the derivative equals, now derivative of sine is cosine, so we have 2 cosine x times cosine x plus, then we're going to have 2 sine x times derivative of cosine x, which is negative sine x. So it's actually 2 cosine squared x plus, I say, is minus 2 sine squared x. And if you recall, this an identity in your formula booklet. This is just 2 cosine 2x, right? Actually, you can do this a different way. Right from the beginning, you can use an identity that's equal to sine 2x, and the derivative of sine 2x is cosine 2x, and then you have to use the chain rule times 2. So this is the same thing. So actually that way is a lot easier in this case. Okay, next we're going to look at quotient rule. So for quotient rule, you could always write it as a product actually. You could write it as x squared times 2x plus 1 to the power of negative 1 and always use product rule. But sometimes we use quotient rule. And the quotient rule states that you do basically the denominator. So this is the form u over v. So you do the denominator times the derivative of the top minus the numerator times the derivative of the bottom, right? Over the bottom squared. So let's do that. This is always in your form of the booklet if you forget how it works. But so basically we do the derivative of the top, which is 2x times the bottom, minus the top times the derivative of the bottom, which is just 2 in this case, over 2x plus 1 all squared. Now often this bottom part can be really, really complicated and we don't need to simplify it. Okay, just leave it as it is. So this is 4x squared plus 2x minus 2x squared over 2x plus 1 all squared, which equals 2x squared, 2x squared plus 2x over 2x plus 1 all squared. Okay, and this next one, I'm going to rewrite this third as x to the power of half. And then we'll differentiate it. So the derivative equals the derivative of the numerator, which is half x to the power negative half, times the denominator, which is 2x minus 1 all squared, minus the numerator times the derivative of the denominator, which is the derivative of the denominator is going to be 2 times 2x minus 1 times the derivative of what's inside the brackets, so you get another 2. That's all over the denominator squared. Okay, so all that equals, now actually let's take a close look here. We've got sometimes you can do, so you simplify this step. So we have 2x minus 1 squared, we have 2x minus 1 squared here. Over here we have 2x minus 1, so you can cancel out a 2x minus 1. And that'll make it a bit simpler. Actually, this was a 4. That's supposed to be a 4, so then we cancel and it becomes a 3. Okay, so we have, now in the numerator, we have half, and let's multiply this out. Or I could leave it like it is. There's no really need to simplify if the question doesn't ask you for it. So we have 2x minus 1. Over here, that's just 4 root x. And in the denominator, we've got 2x minus 1 all cubed. Okay, another example. First quotient rule, then chain rule. Okay, so let's find the derivative using the quotient rule. So we do the derivative of the top, which is 0 times the bottom, minus the derivative of the bottom times the top, over the bottom squared. And that's just 0 there, so you're going to have negative 8x over x squared plus 2 squared. And if you do it the other way, we first write it as 4 times x squared plus 2 to the power negative 1. So dy dx equals negative 4 x squared plus 2 to the power negative 2 times the derivative of what's inside the brackets. So it is the same thing. It's negative 8x over x squared plus 2 all squared. Okay, and the next one, we'll take the derivative by doing the derivative of what's in the top. That's 2e to the 2x times the denominator minus the derivative of the denominator, which is 2e to the 2x, times the numerator, which is e to the 2x, and over 1 plus e to the 2x all squared. Okay, so if I expand this, I get 2e to the 2x plus 2e to the 4x minus 2e to the 4x. So actually those two just cancel. So you get 2e to the 2x over 1 plus e to the 2x all squared. Now tangent, this is actually, well, you can get it in your formula booklet, but to derive the rule for tangent, we can write tangent as sine x over cosine x, and then use quotient rule. So the derivative is the derivative of the top, which is cosine x, times the bottom, which is cosine x, minus the derivative of the bottom, which is negative sine x, times the top, which is sine x. The bottom is just going to be cosine squared x. Okay, so that's just cosine squared x plus sine squared x over cosine squared x. And recall cosine squared plus sine squared is just 1. So we have this, which is equal to secant squared x.